Okay. Now putting R value from Fs equation in this equation. Fc equals to putting the values of R. Fs by cos beta naught plus eta minus gamma 0 into, this is the values of R, into cos of eta minus gamma 0. Now Fc equals to putting the value, now we are putting the value of Fs. Fs means A1 B1 sine of beta 0 tau s into cos eta minus gamma by cos of beta plus eta minus gamma 0. This is our expression. Please write down this expression. All expression, this equation. Okay. Now erase all this. From this equation, what is the value? Now we are discussing about the minimum power consumption. We have already know that at the expense of minimum input we obtain maximum output. So less power consumption and we have to obtain more output. So power consumption formula, work done, work during machining, when tool is penetrated on the job, on the parent metal, for removing material. So there was some work has been done on the job by the tool. So what is that value? Work equals to force into displacement. That means force means cutting force into displacement means velocity. Velocity means meter per second. That means displacement per second. That means work per second. Velocity means displacement per second. So force into displacement per second. That means force into displacement per second. So force into displacement means work, or work per second means power. Okay, very simple. Now erase this. Now putting this value from here. Fc's value, we we have to take Fc value from this equation. Now putting here. Fc value is A1 B1 tau s cos of eta minus gamma naught into V 1 by sine beta 0 cos beta 0 plus eta minus gamma. Now this is power equals to this expression. Now for particular job material, particular machining condition, chip thickness is constant. This is our assumption. Uh, According to volume constancy, width of the job is also constant. If the shear plane is plane, so the tau is constant. Because this in our assumption, along the shear plane, shear force is uniformly distributed. We have already discussed about it. Now, according to tool chip interface, the frictional angle is also constant. Rake angle, this is the tool geometry. Before machining, we will choose the particular tool. For particular tool, the rake angle is fixed because this is the tool signature or tool designation. And cutting velocity is the cutting condition. This is also fixed for particular tool and job combination. So the only variable thing is beta, because shear plane or shear angle is always varies from the tool material, job material, or tool job alignment, or and so on. So this is the constant value. Only variable part is beta naught. So now power equals to this constant, we take k, into 1 by sine beta 0 cos of beta 0 plus eta minus gamma. This is our value. We take this is because this part is constant, so we are assuming this is k for minimize the equation. This is our k. Now because this is the only part which is variable for during machining condition, in terms of machining condition, tool geometry, tool job interface, uh, job material, alignment. So in order to calculate the minimum power consumption, we have to derive in derivative with respect to beta. So dp d power by d beta naught. This equals to 0 if we have calculated this. This is the condition for minimization or maximization. This is the condition for minimization or maximization. If again we derivative again d2p by d beta 2 greater than 0, this is the case for minimum power. Okay, now let's check. First of all, we calculate the minimum power consumption condition dp by dt. Okay, now derivative this simple derivation cos beta, this part is fixed, this part is derivative, cos beta cos of beta 0 plus eta minus gamma. This part is constant, this part is variable minus, now this is fixed, this is variable, sine beta sine of beta plus eta minus gamma by this whole square. This is the form of d of u by v form. D of x is the u by v form by sine beta cos beta plus eta minus gamma 0 whole square. Okay. K is constant because the right hand side part is equals to 0, so K is also 0. So this part is 0. Now cos beta 0 plus cos, sorry, cos of beta plus eta minus gamma minus sine of beta sine of beta plus eta gamma 0 equals to 0. This is the cos AB form. Okay, so cos A plus B, cos A cos B, sin A sin B. So cos equals to cos A plus B. Cos A means beta 0 or cos B means beta 0 plus gamma, sorry, minus gamma plus eta. Beta plus eta minus gamma 0 equals to 0. This is our expression. Now this is cos of 2 beta 0 plus eta minus gamma 0 equals to 0. Cos 0 means cos 90 minus pi by 2. 2 beta 0 plus eta minus gamma 0 equals to pi by 2. This is our equation. This equation is known as Marchant Marchant-Ernst equation. Marchant-Ernst equation. From here we have to, so by this equation we have to calculate the frictional angle beta 0 gamma 0. Simple. Okay. Thank you.